So, y'all, you have a test on Tuesday over 3.1 to 3.4. The stuff you are expected to know, okay? You will have 2 questions about compound interest. One of them, you'll have to use this formula. A equals principal times 1 plus that one. And then one, you'll have to use APERT. Remember, use APERT when it's continuous. We need to know how things are compounded. So annually is once a year, semi-annually is 2, quarterly is 4, monthly is 12, daily is 365, right? Everybody with me? When we talk about exponential logarithmic functions, you guys are going to be given the first page of your test. You'll have like 10 or 12 minutes to do it because you have to answer these questions and graph it without your calculator. The biggest thing is you're going to have to make a table of values and plug in points. All right. I know that's not the greatest thing in the world, but you'll be fine. You need to understand, guys, write this down with me. You need to understand that the domain for an exponential function is always negative infinity to positive infinity. Always. Your range goes hand in hand with your horizontal asymptote. Always. Your horizontal asymptote. All right. Your vertical asymptote is always going to be none for an exponential. How do you find your y-intercept? You plug in what? Plug in 0 for what? For x. Okay. Everybody with me? The only time you'll have an x-intercept with an exponential is if you're moving your graph up and down. And you'll be able to see that when you do your table of values. When you have a logarithmic function, remember, logs and exponentials are what of each other? They're opposite. They're inverses. So instead of the domain being negative infinity to positive infinity, your range is negative infinity to positive infinity. In this case, your domain goes hand in hand with your vertical asymptote. How do you find the vertical asymptote? Anybody remember? You set good. The parenthesis equal to 0. And then that'll tell you your domain. Your horizontal asymptote will be none. Your y-intercept a lot of times, I'd say 90% of the time, is going to be none. It's not going to touch the y-axis. But how do you find the x-intercept? You plug in what? Plug in 0 for y. All right, so we're going to do an example of both of those so you guys know exactly what I'm expecting. But we also have to remember about condensing and expanding. Remember, if something's already smushed together, you're going to pull it apart. If it's already pulled apart, you're going to smush it together. So in condensing, addition becomes multiplication, subtraction becomes division, coefficients become exponents. When you're expanding, vice versa. Multiplication becomes addition, division becomes subtraction, and the exponents become coefficients, right? We talked yesterday about solving. And remember, there's only one pre-calc step when you're solving, and it's when you have to do the inverse. Everything else is basic algebra. So you have to remember that logs and exponentials are inverses of each other. E to the x and ln are inverses of each other. They're on the same button on the calculator. So I tell you guys, the first thing you need to do is isolate, identify the function, so circle it, whatever, get it by itself, and then solve. And you have to remember that you cannot take the log of a negative number. So plug it back in to make sure it doesn't become negative. If you do get an answer where it says x equals, and you take the log and it's negative and it says error, then your answer would be no solution. That is a possibility, so just don't get stuck on that, all right? Let's do these 2 examples together. I don't know why I have horizontal asymptote and y-intercept written twice. Cross that off. I don't know why I did that. So my bad. When I talk about the transformations, we're not asking you that on the test, but I want you guys to be able to visualize what your graph looks like. All right, so that's why I say that. But if you look at this first function, is this an exponential function or is this a logarithmic function? It's exponential. You know it's exponential because there's a variable in the exponent. How would you know if it was a logarithmic function? It would have the word log or it'd have ln in it. So you know this is exponential. So right away you can say what for the domain? It's negative infinity to positive infinity. All right, let's talk about the horizontal asymptote. Horizontal asymptotes, that line that your function is going to get really, really, really close to, but not touch. Your horizontal asymptote is whatever is being added or subtracted to your function. Is there anything there? No. So your horizontal asymptote is at y equals 0. Y equals, don't just put 0. Do you see any negatives in front of this function that's going to make it flip over the x-axis? No. So that means your range is going to go from 0 to what? 0 to infinity. Now, if you don't want to put any of these in, you want to wait until you graph it, that's fine, because you'll be able to see it as well. But y-intercept, guys, how do you find the y-intercept? You plug what? You plug what? For y-intercepts, what do you plug in for 0? Sorry, what do you plug in for x? 0. So I'm going to say 1/3 times 2/3. And then I have my exponent is -2 times 0 plus 1. Now, this is the part of the test. You'll have 2 questions that I'm going to give you guys 10 or 12 minutes to work on. And then I'm going to give you the second part to finish. This should not take you more than 10 or 12 minutes. But if you evaluate this, guys, what is -2 times 0? 0. And 0 plus 1 is 1. So what is 2/3 to the first power? 2/3. So you're saying 1/3 times 2/3 is my y-intercept. What is 1/3 times 2/3? It's not 3/9. What's 1 times 2? It's 2/9. So your y-intercept is at 2/9. How do I write intercepts? 0, 2/9. Good. What's your vertical asymptote? None. Good. And you can answer x-intercept now, but you don't have to. You can see when you graph it what's going to look like. Now, transformations, guys. I'm not asking you for specific transformations on the test, but I want you to be able to recognize what your function should look like. All right? First of all, is this a growth or a decay? How do you know it's a decay? Because that's a fraction between 1 and 0. So it should look something like that, right? Okay. What does this 1/3 in front of your function mean? It's a vertical what? A vertical shrink. Anything multiplied out in front is either a shrink or a stretch. Now, let's look inside the exponent. What does this negative inside the exponent mean? It means it's going to reflect. If it was out in front, it would reflect over x. If it's in the exponent, it reflects over what?
The y.
The y, good. What does this 2 mean? It's a horizontal shrink, right? It's the opposite of what you think. And then this is going to move it where? Left 1, good. Now, guys, think about this. You're saying it's a decay. I agree. What does a reflection over the y look like? Where's it going to flip? It's going to go like this. So it's going to look like a what? Like a growth. If it were to flip over the x-axis, it would flip down. If it flips over the y, it goes left and right. Now, you guys don't have to know that. You don't have to recognize that. I'm just saying, if you can get a mental picture of what it looks like, graphing might be a little easier. But all you really have to do is just make an XY chart. Yes, you have to make an XY chart with fractions, and it's totally okay, all right? I have an x value and I have a y value. Plug in -1, 0, 1, and 2 into our original function. So if I plug in -1, I have 1/3 times 2/3, right? And my exponent is -2 times -1 plus 1, right? Well, what's -2 times -1? 2, and 2 plus 1 is 3. So I have 1/3 times 2/3 to the third power. Well, what does that look like? The 3 goes to the top and to the bottom, right? So I have 1/3 times 2 to the third power is 8. 3 to the third power is 27. Okay. Can't cross cancel or anything. So I have 8 over 81. Yes? Can you guys tell me about where 8 over 81 is? It's in between what? It's in between 0 and 1. All right, so we already did when we plugged in 0. What happened when we plugged in 0? We got 2/9. All right, let's plug in 1. Same thing. This is what's going to take you the longest, and we should be able to do this because we're in pre-calc honors. So I have -2 times 1 plus 1. Okay, so I have 1/3. What is -2 times 1? -2 plus 1 is -1. So what does that mean if I have 2/3 to the negative first power? Well, it flips. Very good. So this just becomes 1/3 times 3 over 2, right? Because it would be 2 to the -1 and 3 to the -1. You flip them, they become positive. What happens with our 3's? So this becomes 1/2. So when I plug in 1, I get out 1/2. Now the last one I'm going to do is plug in 2. So I have 1/3 times 2 over 3, and then I have -2 times 2 plus 1. What's -2 times 2? -4 plus 1 is? -3. So you have 1/3 times 2 over 3 to the -3rd. What's another way I could write that? Yep, 1/3 to the 3 over 2 to the third power. Because that exponent goes to the numerator and the denominator. So 2 to the -3 over 3 to the -3. If I flip them, they both become positive. So this now is 1 over 3 times 27 over 8. Agreed? Can I cross cancel anything? 3 goes into 3 once. 3 goes into 27 9 times. So I have 9 over 8. So when I plug in 2, I get 9 over 8. All right, so you're getting a picture, guys. That's all you're doing. So when you graph this, you're getting a picture. What I'm going to look for, 100% what I'm going to look for, absolutely, is your horizontal asymptote. So where's our horizontal asymptote? At y equals what? 0. So I have my horizontal asymptote. It's my dashed line that my graph's going to get really close to but not touch. And I'm going to look hard for your y-intercept. What was our y-intercept? 0, 2/9. Good. So my other one, when I plugged in -1, I got 8 over 81. When I plugged in +1, I got 1/2, right? When I plugged in 2, I got 9/8, which is just a little bit above. So my graph is going to look something like this. It's going to get close to my horizontal asymptote, not touch it, go through your y-intercept, and your point should kind of go along that line. The hardest part of this, other than remembering what your domain and range, that sort of thing should be, is just plugging in numbers that aren't particularly beautiful. First of all, what can I say already off the bat is -infinity to +infinity? Your range. Good. It's the opposite. Good, 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 good. -infinity to +infinity. Domain goes hand in hand with what? Your vertical asymptote. What is your horizontal asymptote for a log? None. Good. And a lot of times you don't have a y-intercept, but you'll see that here in a second. So let's find our domain and our vertical asymptote. They go hand in hand. How do I find it? You set your parenthesis equal to 0. So I'm going to add 7 to both sides. 2x equals right, 2x equals 7. Good. Now what? Divide by 2 and x equals 7 over 2. How do you write, guys, the intercept x equals 7 over 2? Parenthesis 7 over 2, comma 0. Correct. It is an ordered pair, always. Always, always, always. And that's not, I didn't mean to put that there. I'm sorry. Yeah, I don't know why I did that. That is your vertical asymptote. Sorry. Friday afternoon, to your vertical asymptote. So what is our domain? Well, now you guys, it's either negative infinity to 7 over 2 or it's 7 over 2 to infinity. Your vertical asymptote, like there's our y-axis, your vertical asymptote, and we'll graph it in a second. It's going to be here at 7 over 2. If it's a positive log, it goes to the right. If it's a negative log out in front, it goes to the left. So where is this one going? To the right. So what is your domain? 7 over 2 to what? Infinity. Good. Now I need to find my x-intercept. Well, how do we find x-intercepts? We plug in 0 for what? Nope. We plug in 0 for y. We set it equal to 0. Now yesterday, or before yesterday, you guys wouldn't have known how to do this. I have log base 2 equals, or log base 2 times 2x minus 7. What's the opposite of log? Exponential. So if I want this log base 2 to cancel out, what does my big exponential base need to be? 2. So if I make this 2, everything goes up in the exponent. So I have log base 2 of 2x minus 7. And what you do to one side, you do where? 0. So I have a big old 2, and I raise it to the what? To the 0 power. So what happens here, guys? On the left-hand side, 2 log 2, what happens? It cancels, so you're left with 2x minus 7 equals, what is 2 to the 0 power? 1. That'll happen every time, guys. And now when we solve this, we add 7 to both sides. I get 2x equals 8. So my intercept is at x equals what? How do I write x equals 4?
4, 0.
It's at 4, 0. Agreed? Okay, so let's graph this. My vertical asymptote is at 7 over 2. What is that in between? 7 over 2 is in between what two numbers?
Like 2, 3, 3, 3 and
Guys, 7 over 2. We need to know where that is on a graph. It's bigger than?
Bigger than 3.
Bigger than 3, smaller than 4. Okay, so my asymptote should be in between 3 and 4. If you put it in between any other numbers, you're going to get points off because that's not where it should be. And where did we say that our intercept was? At x equals 4. So right there. And y'all told me this was a positive log, right? So that means it's going to come up next to your asymptote, real close, go through the x-intercept, and make a right-hand turn. And there's your log. So go back to your questions. Did you answer all of the questions? What's one of the questions we didn't answer? Y-intercept. Is this ever going to touch the y-intercept? No, it's not going to touch the y-axis, so this would be none. The only time you have a log that's going to touch is if it's over here on this side and it's going that way. But you guys don't have that.